This elementary property of group is often stated as another theorem or a corollary, which is an implication of a theorem, which tells us that if we let G be a group under a star operation, for all A and B element of G, we have this expression, the inverse of the result when we operate A and B to the same operation star is just equal to the inverse of B star inverse of A. Now, there are things we need to be reminded of here. Number one, of course, this may not be true if we are going to interchange them, A inverse star B inverse, because there's no claim that the group is an abelian or there is commutativity. Similarly, what we can see here that if we have this A star B, the result of this is an element of G. Maybe it's a C or another element, because for this to be a group, it should be closed, right? G should be closed. Similarly, the inverse of the result of A star B is also an element of G. Again, because G should be closed as to, for it to be considered as a group. So from here, we are going to apply necessary operations or analyses. Of course, you cannot use here the power law of exponents and distribute that because it's not possible for this situation. We're going to show that from here, we're going to reach to that situation. So let's have this proof, and hopefully you will stay with me as I show you a sample of the proof of this. So we're going to show that from here, we're going to reach this portion here. Okay, now what we're going to talk about here is this. Operate this by A star B. Okay, so this is on our left hand side. I am operating this with A star B, so we have like something like that. A star, or the inverse of A star B. This would mean there are many ways to show that they are equal. One of which is you manipulate this in reaching into that, or you can manipulate both sides and come up with the same expression. So for our right hand side, I am separating them, okay, so that you will not be confused. So since you're operating A and B to that, we're also going to operate this A star B with B, what do you call this one? This notation here, B inverse star A inverse. Okay? So we are operating it to this, something like that. Okay? We are operating the result of A star B to both of the sides of the equation. Okay? So what does this mean as we take this whole on our left hand side? Since whatever the result of this, let's say let C is the result of A star B, then you will have here C on the left hand side. Sorry for that. C star, this is C inverse, right? As we let C be equal to A star B. So what is now the result if we have C operated with its inverse? This is actually equal to E, okay? The identity element. We just simply use C here. Don't be confused with that because we're just treating this as one. Or if you don't want this, of course, you can simply stick to that. We have here this expression A star B and its inverse. Automatically, if we're going to take its form or result of that under the same operation star, is just equal to E. Let's show that the right hand side, when we add this on the left portion operated with the same star, will result to the same E. Okay. What I would like you to do here is actually use associative property, or you can break this groupings as we have here. Okay, this is the new form. Okay, I'm not going to use equality so that you will not be confused with this as a whole. So you have A star B inverse star A inverse. Take note that we cannot interchange them because there's no claim for commutativity. But I would like you to focus on these two elements as I group them. Okay, because it's possible, because every group as declared has associativity. Okay, just like that. Once you operate B to its inverse, we know that the result is the identity element, star A inverse. Now, I would like you to proceed next Okay, hopefully that this is clear, to the group of A and E here. Okay? Now, when you operate A to any identity, the result here is just the element itself. And the remaining result here, or the remaining term, is just the inverse of A. Similar to what happened to C and B here, once you operate A to its inverse, the result here is E. Now, this may not be the conventional proof, but what I showed you here is when we manipulate both sides of the equation by adding the expression A star B on both sides, okay, on the left specifically, we have shown that the simplified form of the left-hand side and the right-hand side are just the same. With this, we can now say that this property is true, where the inverse of the result of A star B is just equal to the inverse of B star the inverse of A. Again, you cannot interchange them. It should be in this manner. This is properties, laws, and theorems. Please subscribe now.